Hello, good afternoon. We will start the workshop. So we will speak today about the circular economy approach applied to the nuclear sector by Cyclife. So I will introduce myself. I'm Delphine Servaux. I'm the managing director of Cyclife Sweden. So I'm based in Sweden, and we are working with Laurent, who will introduce himself for Cyclife Group, which is a company owned by EDF 100%.
Okay, and I am Laurent Auger, so I am the project manager for the EDF group for the Technocentre Project, which is a project to develop, design and build and operate a new metal recycling facility for very low-level metals.
So we will articulate the presentation first based on Cyclife Sweden, what we are doing, and then we will focus on the Technocentre. I will start with Cyclife Sweden. As I said, we are part of EDF Group and we are part of Cyclife Group. Cyclife has been created in 2016. It has been created at the beginning based on the three facilities, one in Sweden, one in UK, and one in France, in the south of France. So that was really the start of the story of Cyclife Sweden. And then year after year, we have known a quite huge growth within Cyclife. Now we are 10 companies, not working only on the waste treatment, but being capable to work from decommissioning scenarios, building waste treatment facilities, also offering services in the digital services that to support the operations. So the scope is very large for Cyclife, and we are capable today to provide solutions to the customer from the beginning to the end on the decommissioning and waste management. And Cyclife Group today is roughly 1,300 people, and it was much, much less in 2016. So if we focus on Cyclife Sweden, so it has been bought by EDF in 2016. And it's not a new company, a new facility, of course. It was already in operation. It has been bought to Studvik at that time. And EDF bought the metal treatment facility, the incineration facility, and the pyrolysis facility. And that was the start of the journey for Cyclife Sweden. Cyclife Sweden is located 100 kilometers in the south of Stockholm, so in Sweden. And we are today roughly 230 employees. And we were much less a couple of years ago. So we are also in a period where we developed quite a lot. Today we are capable to provide services in waste treatment. So we are speaking about low-level waste and very low-level waste. As I said, we are focusing mainly on metal treatment. It can be for recycling, and it can be also for volume reduction, depending on the waste we have and we receive from our customer. We are also working with volume reduction based on the incineration and pyrolysis. And we also have additional activities where we are recycling all of the sealed source from Sweden. So it's a mandate we have from the Nuclear Authority to do that in Sweden. And we have a lab providing services internally for our own services, but also externally to external customers. I will come back to our capacity on metal treatment, and I will focus a bit on what we are working on right now. If we look at our added value to our customers, so we are capable to provide recycling of metallic waste. I will focus on this one. And we can today provide really a turnkey solution to our customers. It means that we are capable to manage the transport of the waste. So it starts with the transport, the production of the waste, and then the transport. The transport can be by boat, it can be by trucks, so we can manage that. Then we have the waste coming on our site. We are doing the reception of the waste. We are storing the waste because they are not entering directly into the facility. So it can be a couple of months before we start producing the waste. And then if we look at what we are doing on metal treatment, we are entering the material into our facility. First, we are cutting the materials. So we can cut by hot or cold cutting, depending on different parameters. Then we are removing the surface contamination by blasting. And then we are doing the melting. So it means that we do the homogenization of the metal, creating ingots, metal ingots, that then can be measured to secure that we are under the free release threshold, and then can be sold on the market. In parallel, we have the production of what we are calling the secondary waste. It means all of the radioactivity which is left and is sent back to the customer. If we look at who we are working with, so we have happy customers, I would say, in all Europes, and we are quite proud about that. So we are working today mainly for Swedish customers and mainly for Uniper. As you might know, Uniper is decommissioning their facilities in Sweden. So we are providing services to them, and I will come back to that in another slide. We are also working with Vattenfall, both for Forsmark and Ringhals, of course, so also operation and decommissioning. And then we are also working in the Nordics for TVO, Westinghouse. We also have a lot of activities with Germany, so with GNS and also with Preussen Electra. We will receive in a couple of weeks a full-size steam generator from Preussen Electra, so before the end of the year, and they will be proceed in our new facility. We also work with France and with EDF, and we have received 2 weeks ago a steam generator from Fessenheim. So 3 steam generators from Fessenheim. We have already received the first part, the upper part of this steam generator in 2021, and we received the other parts, the lower part, 2 weeks ago. And they will be treated in the facility in a couple of months. And we are also opening the road with Japanese customers to be able to propose the same services to them also. If we focus on Uniper, what we are doing, so Uniper is working on the decommissioning on their plant, and I'm not working for Uniper, but just to explain, it's an 8 years program, more or less, and we are accepting the waste as they are produced by Uniper on our side. So we are following the decommissioning program to really support them and not having too much waste on their side, and we are performing and treating the waste on our side. So you can see where the waste are coming from Uniper. It's what is in red, and we are the other cycle receiving the waste from Uniper. So 4 different NPPs, and we are treating them. We are speaking about 15 tons of material. So it's quite huge. It's a lot of years of production also for us, and it represents more or less 1/4 of the waste that are produced by the decommissioning program of their facility. We are able to reach volume reduction and recycling up to 95%. It means that on these 15,000 tons that have been sent to us, Uniper will get back only 5% in terms of volumes. I just did some comparison that you see more or less what it brings in terms of circular economy. It means that we are capable to avoid the emission of 31,000 tons of CO2. And if you want to compare, I mean, it's more or less 70 times that you are charging your million times you are charging your phone. So just to give a magnitude. 7 million times of charge of a smartphone. If we look at what we are also doing for EDF, I already mentioned the fact that we have received and we have also treated the upper part of 6 generators from Fessenheim. So the reception of this material has been done in 2021, and we have treated this material in 2023. It has been a great success because we were capable to recycle 100% of the metal that we received. of course, is the upper part. So it's quite clean part of the steam generator, but we were super proud also to be able to reach that. And we will start the other part with the lower part where we have the tubes. It will start in the new facility. I'm speaking about the new facility for several slides, and I will discuss about that also now. We have already a capacity to treat today up to 5,000 tons of metal per year. And we are right now increasing this capacity to 10,000 tons per year. It means that we are doubling the size of our capacity to treat metal, which is huge. And we are the only facility under construction right now. So we are more or less at the end of the project. We started the construction beginning of 2024 after studies, building permit, and all of the regular processes before that. But the construction started less than 2 years ago. And right now we are performing the test of all of the equipment in the installation to be able to start the commissioning beginning of 2026. When we will have the operation full and running for this facility, so we will be able to treat, as I said, 10,000 tons. And it means that we will be able to treat each year more or less 1 Eiffel Tower with our 2 combined facilities. I will hand over to Laurent, but what I wanted to say is that what we try to do at Cyclife Sweden is really transforming a liability into an asset and contributing to the circular economy as much as we can. We are working with a future that is quite bright. It means that we have a lot of material to be treated in front of us. It's huge what is available all around the world. We are also innovative because we are using new equipment all the time. So we try to stay really on the cutting edge technologies. And of course, we are sustainable. The management of the waste can really be part of the circular economy. And what is also super important is that it's a criteria for all of the new build projects to be able to show and to demonstrate that we are capable to manage nuclear waste.
Okay, so I will now continue with the presentation of the Technocentre Project. So I will follow the following outline, the project background, project essentials. Then I will explain the specificity in France, or industrial process. You will see it's quite close to the one described by Delphine, but it's a much bigger facility. And then I will give you an insight about the project time frame. So the project background, as I told you, we are talking about recycling of very low-level metals coming from nuclear facilities. Recently, following a public debate in 2019 in France regarding radioactive materials and radioactive waste, there was a change in the law in 2022, which opened the possibility to recycle metallic components from nuclear power plants. So there was a change in the safety public code, le code de la santé in French. And the aim is to, after a specific treatment in a facility, to completely recycle the metallic components and to release it in the conventional area without any specific restriction nor any specific traceability conditions. The project is also very related in terms of context to the final shutdown of the Fessenheim nuclear power plant in 2020. And clearly the project proposed by EDF is also a project that is really inside the territory development project within the Fessenheim area after the final shutdown of the plant. And the project will be located on the Fessenheim nuclear power plant in the east of France. That was a very important step of our project. End of last year and beginning of this year, there was the public debate on the Technocentre Project. Donc le débat public sur le projet Technocentre, which took place, and it was really a good step to explain the project to the public. And following this public debate, there was the decision made by EDF in July 2025 to continue the project, taking into account what was expressed during the public debate. I think I need to go a bit faster. Okay, so there it is. So quickly, the essentials of the project. So you understood it's a circular economy approach. Clearly, it will be new in France to be able to recycle metals coming from nuclear facilities. Today, well, at least before 2022, it was not the case. Any material before that would come from a certain part of a nuclear power plant would be deemed as a radioactive waste. So it was before. Now, thanks to this evolution of the law in 2022, and thanks to the Technocentre Project, we will implement recycling of metal, very low-level metals in France. The facility will be ECPE, so it's the status. It's a facility for the protection of the environment. So it will not be a nuclear facility. It will be a ECPE, mostly because the radioactivity present on the site will be much lower than I would say that the threshold that relates to an ENB in France. You understood the aim is clearly to produce ingots that will be used in the conventional area without any restriction, especially outside of the nuclear industry. As you well understood, within Cyclife we have a big experience in this area, especially with the activities of Cyclife Sweden that were presented. As I said, the project will be, the facility will be settled in Fessenheim, and in terms of planning, the industrial commissioning of the facility is planned to be in 2031. The objective in terms of recycling is to have a recycling rate of about 85%, meaning that from all the metals that will arrive to the Technocentre, about 85% in terms of mass will be valorized and sent to the conventional industry. So the metals will mostly come from French nuclear facilities, especially nuclear power plants, especially EDF nuclear power plants for the decommissioning of those nuclear power plants, but also from facilities for I would say the fuel cycle for the fuel cycle, especially from also other French producers like Orano and the CEA. And the types of components that will be received and treated at the Technocentre is especially steam generators from EDF, as you can see on the picture, piping, heat exchangers, pumps, etc. And it will represent about 500,000 tons over the full operation duration of the Technocentre, which is about 40 years. And there will be a great advantage in terms of impact. We will spare about 450,000 square meter in terms of need for final disposal of waste. So it will be a very huge, I would say, waste volume reduction for final disposal in France. So we will produce in the facility ingots, either cast iron ingots or steel ingots, about 20 kilogram each. So it will clearly be in compliance with the thresholds that are defined in the French health code, especially that the additional dose coming from the ingots will have to be less than 10 microsieverts per year, which is, to give you an order of magnitude, it's about 300 times less than the natural radioactivity. Let me present to you the industrial process. So actually, it's very close to the process presented by Delphine. I would say the biggest difference is that the Technocentre facility will be much bigger. The total capacity will be about 20,000 tons per year. We will have 25-ton electric arc furnace. So you can see that we will receive either large components like steam generators or scrap metals. We are able to do decontamination if needed. It's not compulsory in our process, I would say. Then cutting and then melting within the electric arc furnace. The overall objective of the melting step of the process is to further segregate some radio elements to, I would say, to complete, I would say, the radiological decontamination thanks to the melting, and also to get a very homogenized component media to be able to do very reliable controls in terms of radioactivity. It's also I would say the main objective of the melting is to have to do a measurements in terms of valorization, which is done on a very homogeneous material. So we are able to demonstrate that the sample we are going to take from the molten metal is representative of the ingots that are going to be produced on all points, and that's very important in our demonstration. So the facility here, you can see the picture. So it's the nice picture of the Fessenheim nuclear power plants. You can see in blue the land plot that is seen for the implementation of the Technocentre facility. It's about a 15 hectares surface of land, and it's right near the facility, the Fessenheim facility, which will be at the same time, at least for the first year of the operation of the Technocentre, still under decommissioning. Yeah. Yes, quite some figures. I already said we will have a storage capacity, especially we will be able to store five steam generators on our plant before entering in our processes. Also be able to store 300 containers of either scrap metal or large components. And as I told you, we'll have very large capacities, 25-ton electric arc melter, and about 20,000 tons per year in terms of treatment capacity. The Technocentre will be, I would say, a facility without any equivalent today in the world in terms of capacity to recycle very low-level materials from the nuclear industry. I will finish with the project time frame. So as I told you, there was the public debate that ends beginning of this year. We will submit the regulatory file to the different authorities in 2026, so for the licensing. We will need an environmental authorization. And then there will be the updation of this authorization, and then the starting of the works, the on-site works between 2025 and 2031. And the aim, as I told you at the beginning of the presentation, is to commission the facility by the end of 2031. And I will finish with this slide. So now I think it is time for question. I think we have 25 minutes for questions. Okay, so I understand we change rooms. Okay. For the questions in the other room.